Section 2, ellipses. This will be the second video on Section 2. Now the reason why I wanted a 2-video situation is because there's a derivation at the beginning of the section that we don't have room for here in the notes that I wanted to go over in a separate video. That separate video is optional. So hopefully I stated it in the first video. If not, I'll go ahead and put it like in the caption or the title that it's going to be optional. Somewhere it's going to be optional. The one that's mandatory, or the one that you need to be able to finish the homework, or if you're an STC dual enrollment, the one to finish the exam, would be this right here, where we go over some example problems. So in the first video, we just derived the formula for the standard form of an ellipse that's oriented horizontally. So there are horizontal, vertical, and there's also any type of orientation for ellipses. So let's say we have a generalized ellipse. Well, first off, before we do that, the definition of ellipse, we'll go ahead and restate it. An ellipse is a set of points in a plane, the sum of whose distances from two fixed points is constant. So you take one point, and that's not a fixed point. So you take one point P, and what you do is you take two other points, we'll call those the focal points, and we take the distances between those focal points and that point P, combine them. And what we want is every point P that comes out to the same combined sum. And if you do that, you're going to come up with an ellipse curve, or an elliptical curve. So let's see, each fixed point is called a focal point or a focus. So I called them focal points, but simpler, focus, plural, foci. Parabolas only have one focus. Ellipses, and you're going to see hyperbolas, will have two foci. Now there's a couple of terms here. I'm going to probably make a bigger drawing for that. So for this particular textbook, and then for other textbooks that you should see. So let's say I have some sort of an ellipse. An ellipse can be drawn anyway, oriented anyway, like slanted in this case. Now an ellipse is an elongated circle. Now actually circles are special cases of ellipses, but we could think of a circle and then elongated along one axis. Ellipses are symmetric linearly two different ways. So there's one, if we want to think of this as the horizontal axis, the longer of the two axes, and if I take, because axes are forever, they're lines. So if I take this axis of symmetry and we have another axis of symmetry, and what we consider are the intersection points with the ellipse and those axes of symmetry. So if we take the two intersection points for one axis and we think of the distance between it, then we want the larger distance, and the axis of symmetry that has the larger distance is referred to as the major axis. So this is the major axis, and this is the minor axis, the one whose intersection points have a shorter distance between them compared to the other one. So this is the minor axis. Now, depending on the textbook that you're looking at, this particular textbook, I believe, calls all four of those intersection points vertices. The pre-AP textbook that I no longer use for the pre-AP class, because now I use this textbook, which is the STC textbook, with my pre-APs. The orange book that you might have seen that other pre-cal sections use in our campus, that textbook will call these two the major axis intersection points vertices. So that's a vertex. This is a vertex, and there's only two vertices, according to that textbook. These two are called co-vertices. So that's a co-vertex, and this is another co-vertex. This textbook, I believe, calls them all vertices. So two vertices, two co-vertices, one major axis, that's where the vertices are at, one minor axis, that's where the co-vertices are at. Okay, also, the intersection point of the two axes is known as the center of the ellipse. So that is the center of the ellipse. Also along the major axis, the center happens to be along the major and the minor axis, but also along the major axis, we have two other points. You have to be careful where I draw them, or maybe I don't know enough about this ellipse to know where those vertices are going to be. Or not the vertices, sorry. These two are the foci. So that's a focus, and this is another focus. Those are the major characteristics of an ellipse. And there's going to be some extra stuff here that I'm going to go ahead and label. So there's distances that I will also want to label. But there are 1, 2, 3, 4, 5, 6, 7 points of importance. The center, which is the intersection of both axes. The co-vertices, which is the intersection of the minor axis with the ellipse itself. The vertices, which are the intersection points of the major axis with the ellipse itself. And then also along the major axis, we have the two foci. So really, really important. The focal distance, C, that's the distance between any one of the foci and the center. So C from here to here, and also C from here to here. So first major bit, very, very important. So what else? The major and minor axis lengths, those are also very important. The numbers A and B. The value A is the distance between the vertex and the center. So A is the half length of the major axis. So from one vertex to the other, shortest distance between would be 2 times this value A. So the length of the major axis, my major length, so major length is 2A, which if you remember, that's actually K from the derivation of the first video. Or if you didn't see it, you don't. The minor axis length is going to be 2 times B. If you remember, B is the distance between this co-vertex, and I should probably do that in a different color. So that, and then that. So from here to here, this is B. And that's the distance between any one of the co-vertices and the center. That's also going to give us the minor length. So the length of the minor axis, I'll call it a minor length, is 2B. And then we have the focal length, which I labeled first, and I hadn't written it down, but let me write that down here. So the focal length. So we called it C, but if you want to refer to this as the distance between the two foci, then that would be 2C. So if you wanted to find the focal length to be the distance between the two foci with respect to each other, then that would be 2C. It's only C if it's between the focus and the center, or one of the foci and the center. And then the thing that related all three of these numbers is that C squared is equal to A squared minus B squared. So that's how A, B, and C are related to each other on an ellipse. So the half of the focal length squared is equal to half of the major axis squared minus half of the minor axis squared. So C squared equals to A squared minus B squared. That's the focal equation for an ellipse. So that's extremely important. So what we're going to do and concentrate on in this particular topic or this particular section is we're going to be either given the equation of an ellipse and we need to graph it out, labeling all this stuff where the foci are at, the vertices and the axes, the center and all that good stuff. Or they might give you some information. They'll tell you the minor axis is this long, the focal distance is this long, find the equation of the ellipse. So either given an equation and then finding out the characteristics of that ellipse, or going backwards, given some characteristics of an ellipse, find the equation of that ellipse. So then we'll talk about the equations of an ellipse. The standard form of the equation of an ellipse that is oriented horizontally, centered at the origin, is given here, this first equation. So this is a horizontal ellipse, most important, and the center is at 0, 0, so the center is at the origin. X squared over A squared plus Y squared over B squared is equal to 1. So then they're giving us the equations for where the vertices are at. Vertices are plus or minus A comma 0. Since we're talking about this being horizontally oriented, then the two vertices are along the x-axis. The co-vertices are along the y-axis, and they're not calling them co-vertices. They're just saying that these are the endpoints of the minor axis. So endpoints of the minor axis, also known as co-vertices. Foci, they're giving us the locations of the foci. It's C away from the origin, so it's plus minus C comma 0. So that should make sense. And then, of course, C squared is equal to A squared minus B squared. Here they're going to take the ellipse centered at an origin, or centered at the origin that is vertically oriented, so this is a vertical ellipse, they're going to switch B and A. So A, they're taking to be the bigger of the two numbers. So we're not going to really care which one's A, which one's B based off of the equation. If it's all we got to do is make sure that we be careful with which one's the larger one of the two. And then in this case, C squared is equal to B squared minus A squared, because in this case, let's see, I'm not sure if that's actually correct. It's always A squared minus B squared. It's always the bigger minus the smaller. And in this case, oh yeah, A is the bigger. And if A is bigger, that's going to result in a negative number, which doesn't make any sense. So I think there's a bit of a typo here. It's always A squared minus B squared, where A is the larger. So yeah, A is always going to be the larger one. And then you always do A squared minus B squared, assuming that A is the bigger one. But oh well. So let's just go through some practice problems really quick, which this one's just going to ask us to graph. Example 2 is very similar. Write the equation of the ellipse having center theta. No. Okay, so we'll go with example 1 really quick. And here they want us to graph each ellipse, find the coordinates of the foci, give the domain and the range. And I'm going to do maybe one of these. So I'll do letter A. 4x squared plus 25y squared is equal to 100. And you'll notice this doesn't look like the standard form of the equation of ellipse. That's because it's not written in standard form. What's in standard form? These are the same equations really, it's just which one's bigger. It's x squared divided by some number plus y squared divided by some number. Most important though, equals to 1. So that the right hand side needs to be 1. Here we have 100. So what's the mathematical way of fixing that? So we already have the form that we want, an x squared plus a y squared on the left hand side. I don't want to mess with addition and subtraction. So I'm probably going to use multiplication or division. In this case, division by 100. You divide both sides by 100, and you should get x squared over 25, because that's 4 divided by 100 reduces to 1/25. Y squared over 4, because that's 25 over 100, and that reduces to 1/4, and that should equal to 1 in the end. And this is the equation we're trying to graph. And from that, immediately I see that A is 5, and B is 2. So A is 5 and B is 2. Where did I get that from? So in the equation, it's A squared on the bottom, B squared on the bottom. So in other words, the number that you see present is the square of the value of A and the square of the value of B. So if the number on bottom is 25, it's the square of A. So what number squared gives me 25? That would be 5. What number squared gives me 4? That would be 2. Okay, so what's the importance of these numbers? Those numbers tell me how large the ellipse is in either dimension, either direction. So A is 5 means that the major axis is 10 long. B equals to 2 means that the minor axis is 4 long. And this is centered at the origin because I see no shifts left or right. So there's no x minus a number, y plus a number, something like that, inside the squaring operation. So that's centered at the origin. So we're centered at the origin 0, 0. And that means A is going to equal to 5 will tell me that we have a vertex at 5, 0 and negative 5, 0. So that's what A tells me. B equals to 2 tells me that there's a covertex at 2 or 0, 2, and then another covertex at negative 2, 0, or 0, negative 2, sorry. So I completely botched those coordinates. Y-axis meaning it's a 0x coordinate, that should be 2. 0 and negative 2. This one over here is 5, 0, and this one here is negative 5, 0. And those are the vertices, the 2 vertices and the 2 co-vertices for my ellipse. So then all I have left is to finish graphing it. And I don't know if they wanted anything else labeled. We'll see. And I'm usually really bad at drawing these things. Ellipses are actually worse for me than circles. And this one's not too bad. That one's good enough for me to keep. So let me go back and read the directions. Graph each ellipse. Find the coordinates of the foci. So those I don't have. So I'm still missing the coordinates of the foci. So how do I do that? The foci are some distance away from the center along the major axis by a value of c. So I need to know what the value of c is. C squared is equal to a squared minus b squared. Forget about that a squared and b squared difference between those other two. Not a big deal. It's just whichever one's bigger, that's the one you're going to subtract from. So the bigger one is 5 squared, then it's minus the other one, 2 squared. So that's going to be 25 minus 4. And you get 21. So c squared is equal to 21, which implies c is equal to the square root of 21. And remember, c is a geometrical value, or it corresponds to the length of a geometrical figure, so it's going to be positive. So it's not going to, we're not going to consider the negative situation. So c will equal to square root of 21. So what that means is square root of 21 to the right and to the left of 0, 0. So square root of 21, that's 21 is bigger than 16. So what that means is the square root of 21 is bigger than 4, but it's smaller than 5. So somewhere around here. So those foci are extremely close to the vertices. So I'm going to call that F1 and F2. I should probably zoom in on that a little bit more. That's as much as I can zoom in. So F1 and F2, I labeled them, and I need to find the coordinates of those. So then the foci. Negative square root of 21, comma 0, and square root of 21, comma 0. If you want to be lazy, you could do it this way. So, or, this is the other way to do that, plus minus the square root of 21, comma 0 would be good enough. That's where the foci are at. That's going to be it for example number 1. I'm not going to do letter B. Letter B, you're going to end up dividing by 441, and you're going to end up getting a larger number underneath y than you did for x, and that's going to make it a vertical ellipse. So we're going to go over more vertical situations. Just want to move on to something a little bit tougher. So I'm going to look at example 2. Write the equation of the ellipse having center at the origin, foci at negative 5, 0, and positive 5, 0. And then we have a major axis of length 18 units. So we're centered at the origin, so what that tells me is that the equation is x squared over maybe a squared plus y squared over maybe b squared. The only difference, I might have to switch a and b. I don't really care which one's which, just a is the bigger one, so that's why I'm thinking we have to be careful with which one is which. So this equals to 1. So what do they tell me? Centered at the origin, that allowed me to write this full equation without shifts, and so we don't have to worry about translations whatsoever. They told me that the foci are at negative 5, 0 and 5, 0. So if I wanted to graph this, that's along a horizontal axis of symmetry, actually the x-axis. So the center looks like it's 0, 0 based off of just those 2 points if they hadn't told me, which they did. But you could just take the center of these two and find out, or you can find the midpoint between those two, and that would be the center of the ellipse. So if they didn't tell you where the origin was at, they just gave you the foci, or they gave you the vertices, or they gave you the co-vertices. You would take the midpoint between those 2 points. If this were a tougher situation, you would take the midpoint of any of those 2 pairs of points, and you would find the center of the ellipse. In this case, negative 5, 0, 5, 0, that's obviously the origin. So negative 5, 0, and 5, 0. Looks like it's very similar to the one that we just did. Negative 5, 0, positive 5, 0. Oh no, those are the foci, my bad. So no, it's not similar to the first one. So this is focus number 1, focus number 2. This is the center, which I'll label as C, which probably shouldn't use that as C. Just call it O for origin. So that's focus 1, focus 2. And then they told me, okay, so there's more information. And major axis of length 18 units. So the entire major axis measures 18 units. That's from one vertex to the other, one endpoint to the other. So I might have to extend this a little bit more. And if that means it's 18 all the way through, halfway it's 9 and 9. So negative 9, 0, and 9, 0. Hopefully that makes sense, because then that would be a total distance of 18 all the way through. So what does that tell me? That tells me that A is equal to 9, or A squared. I can actually leave it that way, 9 squared. So then A is equal to 9. So if you remember, A is the distance from here to here. So that would make it 9. They're not asking me to graph this, are they? No, just says write the equation. So once I figure out I think the value of B, that's it. So I'm just missing the value of b. So what would that make b? And I have to go with an equation, I believe. The equation is c squared. It's always c squared is equal to a squared minus b squared for an ellipse. A is always the bigger, b is always the smaller. So it's 5 squared, I believe, equals to 9 squared minus b squared, which I don't know b squared, so I'm going to have to solve. Now I might have to move some stuff. B squared is equal 9 squared minus 5 squared. I subtracted 5 squared both sides, I added b squared both sides. So then b is going to equal to the square root of that. So that's 91 minus 25. 91 minus 25. It's a little early in the morning right now that I'm recording, so I'm going to have to use a calculator. Forgive me for that. So 91 minus 25. My UIL students probably be ashamed of me right now. Square root of 66. So then I want to plug that in to the equation. So that's x squared over 9 squared is equal to, no, not equal, sorry, plus y squared over square root of 66 squared is equal to 1. Which I'm not going to leave it that way. I'm going to go ahead and square both of those things to make it look nicer. I don't want to square root on that. So x squared over 81 plus y squared over 66 is equal to 1. And there's the equation written in standard form given the information that I have. So foci were negative 5, 5, comma 0, and then the major axis had a length of 18 units. So from there we were able to figure out the rest of the equation. So that's basically all we're doing for the rest of this section, and the next section is going to play the same way. So we just know the equation and how those numbers that are in the equation or the pieces of the equation relate to the geometry of the figure that we're talking about, and we just play around with numbers. They'll give you some numbers, find the equation. They give the equation, find the numbers. So that's example 2. We'll move on. I'm going to skip example 3. I'm not going to give you anything like that in the homework or the test. Okay, after we translate ellipses, so the first situation is horizontal. The other situation is vertical. Horizontal, and I'm misspelling the word horizontal. That's an O here. So for the horizontal situation, a squared is underneath x. A squared is the bigger one. For the vertical situation, a squared is underneath y. A squared is the bigger one. So the variable that has the bigger number dividing it is going to tell you if it's horizontal or vertical. If the number underneath x is larger, then it's horizontal. If the number underneath y is larger, then it's vertical. That's how you would know. But it doesn't matter. You wouldn't want to remember that and try to memorize too many things. The number underneath x is how big that axis is. The number underneath y is how big that axis is. Or it's related to how big it is. So obviously the one with the bigger number is going to be the one with the bigger axis. So the major axis is going to be horizontal. That's y equals 2. They want an equation here for the geometrical figure. So the equation used to be y equals to 0, or the x-axis, but it's been shifted. How much has it been shifted? K up. So y is equal to k. The vertices, they were on the x-axis, plus or minus a, away from 0, 0. Now that vertex has been shifted up by k units. So this is going to be, there's a little bit more to that. So I probably want to draw this out. So it's best if I drew this out. So we have two axes, the minor and the major, doesn't matter what order you draw them in. The intersection point of the two is the center, and the center is now at h comma k. That makes the minor axis x equals to h now instead of 0, and that makes the major axis y equals to k. So we'll start off with that. The vertices, here and here. Remember, this is a distance of a this way. So you would take h, add a, comma k, would be one of those. The other one, you take h and you're moving to the left a, so you would subtract a, comma k. Those are the two vertices. So I see h plus or minus a, comma k. H plus or minus a, comma k. So the vertices are along the same major axis, so the y coordinate should be k. It's the x coordinates we got to be careful with, and I needed the drawing for me to figure out what those coordinates were going to be. The y coordinate was easy because it's along the major axis. Same idea for the co-vertices. Co-vertices have an x coordinate h, but the y coordinate is going to vary. So if you remember, this is b from here to here. So then it's k plus or minus b, because it's b up and b down. So that's going to be k plus b for the one on top, h comma k minus b for the one on the bottom. And I'm only missing the foci. So let's say the foci are here and here. Then that's going to be h plus and minus c comma k. So h, in this case, this is minus c comma k. So there's my rough drawing of what's going on there. So vertices are there. There's also two other vertices, and we said they were at h, k plus minus b, and that's also including the co-vertices. And then this was h plus minus c k. So that's how we figure out what those points are. Now for the vertical situation, you don't want to memorize these equations or these formulas whatsoever. You want to draw it out like I did here. This is the way that I'm going to do this every single time if I'm given an equation. So then we'll start with the center, find out where the axes are at, and then we figure the vertices from there. And there's going to be numbers involved, so it's not as general as this. So it's not a good idea. I wouldn't recommend you memorizing this and going by those equations. Now, of course, if you're working on your homework with the notes, of course, it's easier to see the notes and just to apply the formulas, no problem. But you want to practice doing this, graphing it yourself. So for the vertical situation, our major axis is now vertical, no longer horizontal. That's going to be x equals to the x coordinate of the vertex, or sorry, not the vertex, sorry, the center. That would be h, so x equals h. So if we're thinking of one that's now vertical, so then your major axis is vertical, and that's x equals h. Your minor axis is now horizontal, that's y is equal to k. Center, still at hk. And then they're going to ask for the vertices. So vertices are specifically these two guys. So that's going to be h, k plus minus b. So h, k, and that's going to be minus b in this situation. So the two vertices, h comma k plus minus b, which I'm going to take that to be strictly vertices, not co-vertices. So we can see the big differences between the two. And then the foci are also going to have a x coordinate of h, and it's going to be k plus minus c. And I'm kind of wrong here, aren't I? That's not b anymore, that's a now. If you remember, a is how big the major axis is, halfway. So this is a. So that's plus or minus a here, not b. Because I think of a as horizontal only and b as vertical only, but that's not the case. A is the larger one, so it's gonna switch between horizontal and vertical. B is the smaller one. So if we're talking about the vertices, we want the larger one, which is always a. Your foci are up here and down here somewhere. And that's a distance of c this way and this way. So that's why that one's h, comma k plus or minus c. Now hopefully that's pretty straightforward, simple to understand. What we're going to do is we're going to go and look at some examples. And I'm going to skim ahead really quickly. There's an example 4, and it goes into eccentricity, which I'm not going to cover eccentricity. A couple of word problems, and I'm not going to cover any of those. Yeah, we're just going to do example 4, and that's going to be it for this particular handout. So graph x minus 3 quantities squared over 36 plus y squared over 9 is equal to 1. Give the domain and the range, which I believe they asked me for domain and range for a previous problem, and I didn't do it. I don't really care about domain and range. Those are easy. It's an algebra 1 problem. But anyway, so we have x minus 3 quantities squared over 36. Clearly a is underneath x. So the larger number is underneath x, making this horizontal, not vertical. So then, what's the value of a? A would be the square root of that number, 36, which is 6 in this case. That makes b 3, because 3 squared is 9. What does that make c? Well, c is equal to the square root of the difference of those two numbers. We subtract 36 minus 9. So you just take those two numbers, you subtract them in the order that makes it positive. So 36 minus 9. That would be square root 27. Which 27 is not a square number, but 27 is divisible by a square number. 27 happens to be a cube number. That's 3 squared of 3, because 27 is 3 times 9, 9 comes out as a 3. But if you take the square root of a cubic number, it's the cube root times the square root of the cube root. So 3 squared of 3. Like square root of 8 is 2 squared of 2, and so on. So then we've got to graph this. And we said this was horizontal. So this is horizontal. And that's because 36, the bigger number, is underneath x. That's the reason why. Oops. So the 36 is underneath the biggest, or 36 is underneath x. 36 is bigger. That makes this horizontal. So the major axis has a length of 2 times 6, which is 12. Where's it centered at, though? So center is at, it's supposed to be 0, 0, and the y-coordinate's still going to be 0. But because of the x translation, x minus 3 quantity squared, there's going to be a horizontal shift. And it's a horizontal shift of 3 to the right. So that's positive 3. Positive 3, 0. So I'm going to graph 3, 0 as the center or the origin. I'm going to call that O. So it's not O for origin, but for the center. And I don't want to use C for center because I'm already using C for the foci. And then we are taking A equals to 6, so 6 to the right, 6 to the left, so that means 9, 0 is one of the vertices. And then negative 3, 0 is another one of the vertices. My co-vertices are 3 up and down from the center, so one here and one here. And those are the endpoints of the two axes, which I can use to draw my ellipse, something like this. Now I'm keeping that, kind of messed it up in the last quadrant. And what do they want? They want the graph, and they just want the domain and the range. I'm calling the graph done. Domain and range, I'm going to go ahead and give it. So what's the domain, what's the range? So the domain would be every x coordinate for every single point on that curve. And the x coordinates begin at negative 3, and they stop at 9. So the domain is negative 3 to 9. What about the range? I'm writing in red, kind of don't care. The range would be, if I took any point on that ellipse, what are the y coordinates? And those range from negative 3 to negative 3. And I'm using square brackets because there are no holes, no missing points, no discontinuities. There are points defined with x coordinates equaling to negative 3 and 9. And there are points defined with y coordinates negative 3 and positive 3. And I wrote a negative 3 twice. And that's basically it for example 4. That'll be it for the section as well. So I'm going to go ahead and stop it here. And then we'll see you again for section 3, which there's probably going to be 2 videos for that too.